Spacecraft on the far edge of our view of the Sun caught a signal on August 21, 2025, coming from a patch of the Sun's surface facing away from Earth entirely. It looked completely unremarkable, the kind of thing solar scientists log and forget about by the next morning. 19 days later, it was still going. By the time anyone understood what they were actually looking at, it had taken 4 separate spacecraft scattered across the inner solar system to see the whole thing, because nothing we've built was positioned to watch it start to finish. Not one machine caught this story alone. It had to be assembled afterward, like a puzzle where every piece came from a different camera. This is the longest solar radio burst ever recorded, and the story of how we saw it is stranger than the burst itself. Here's what makes it strange. The Sun puts out radio bursts constantly. This particular kind is called a Type 4 burst. It happens when fast-moving electrons get trapped inside loops of the Sun's own magnetic field and radiate energy while they're stuck there. Most last a few hours. A long one might make it a few days. Before this, the longest ever recorded held for 5 days. That was the record, and it had stood for a while. The first spacecraft to see this one was Solar Orbiter, a joint mission between the European Space Agency and NASA, built to get closer to the Sun than almost anything before it. And the detail worth sitting with? When Solar Orbiter caught this signal, the spot it was coming from wasn't facing Earth at all. It was on the far side, which meant every other spacecraft we have near the Sun, the ones built specifically to watch it, had no idea anything was happening. For 12 days, none of them had it in view. Then the Sun did what it always does. It turned, slowly the way it always turns, once every 27 days or so, and on day 12, that same patch rotated into sight of 2 more spacecraft, NASA's WIND mission and the Parker Solar Probe, the one built to fly closer to our star than any human-made object ever has. A day after that, a 4th spacecraft, Stereo A, picked up what was left of it. The signal finally went quiet on September 9th. 4 spacecraft, 3 separate windows of visibility with a gap in between. 19 days from first light to last, nearly 4 times longer than anything ever documented before it. So the real question isn't just what happened up there, it's what could possibly keep something like that alive for 19 days without burning out. A burst like this usually dies fast because the electrons producing it eventually escape the magnetic field holding them, or lose their energy, or simply run out of fuel. 19 days means something kept refilling it. To find out what, researchers first had to solve a smaller problem. Nobody could even pin down exactly where on the Sun this thing was coming from. The tools to do that at this scale didn't really exist yet, so the team built one. They developed a new technique using data specifically from Stereo A, using it almost like a tracking beacon, to work backward from 4 separate partial observations to a single point of origin. What they found was a structure called a helmet streamer. Picture a total solar eclipse, the ones where thin, pale arcs of light seem to reach out from behind the blacked-out Sun, like something breathing. That's a helmet streamer. It forms where 2 regions of opposite magnetic polarity meet on the Sun's surface, and the field lines between them arch upward into a loop, tapering to a point, shaped roughly like the peak of an old knight's helmet, which is where the name comes from. Solar wind stretches that loop outward, sometimes for the length of the Sun's own radius or more, into a long, thin tail pointing into space. That's the structure. Here's the theory for why it held on so long. Around that same spot, 3 separate coronal mass ejections, huge outward blasts of solar plasma, went off, one after another. Researchers think each one topped up the same pocket of trapped electrons before it had the chance to fully drain. The paper describing this calls it a corrotating electron reservoir, a reservoir that rotated with the Sun itself, refilled again and again from the same source for the better part of 3 weeks. 2 things worth being exact about, because they're easy to blur. First, the radio waves themselves never posed any danger. They simply radiated outward and either reached us or didn't. What actually matters is that the same magnetic conditions capable of producing a burst like this can also hurl charged particles toward Earth, the kind that interfere with satellites and spacecraft. That's the real reason this matters beyond curiosity. The more precisely scientists can trace events like this, the earlier they can warn us before the dangerous kind arrives. Second, this is not a fast radio burst. At least one outlet covering this story called it that, and it's a real mix-up worth untangling. FRBs come from deep space, likely neutron stars or magnetars, in galaxies light years from here, and in most cases, we still don't know exactly what's producing them. This happened inside our own solar system, from our own star, and by the time this paper was published, scientists had traced it to an exact structure and a specific cause. Different phenomenon, different distance, different level of certainty entirely. What actually stays with me isn't the record. It's the 12 days in the middle where nothing had it in view. We tend to assume that when something extraordinary happens in space, we're watching the whole thing as it unfolds. Usually we're not. We catch fragments, one machine here, another one 9 days later, and most of the time, nobody ever goes back to stitch them together into a single shape. This time, 4 spacecraft, built years apart for entirely different jobs, happened to be positioned well enough that when someone finally lined up everything each of them saw, the pieces actually resolved into something whole. 19 days, 4 spacecraft. One signal handed off across the solar system, until, for once, we got to see the entire shape of what the sun had done.